Now let me show you how to recover the experience utility function from an observed demand behavior. So again, remember the nature of the exercise. Suppose that I observe your behavior at some prices, P1, P2, and P3. I observe how much you demand, let's say those points. From that data, I use statistical or econometric methods, and I recover your behavior for any price, i.e. your demand function. Remember also, as we saw before, that from that I can invert the demand function to construct the inverse demand function, P star of X. Now, why is this useful? Because remember two things. First, we are assuming that preferences are quasi-linear, i.e. U is quasi-linear. So it has the form, just to remind you, U of X comma M is equal to B of X, some benefit function, plus M. And the second is because, as we saw before, this locus P star of X, the inverse demand function, is equal as long as the preferences are quasi-linear and, very importantly, individuals are optimizing, is equal to the marginal benefit function of X. But from here, we have everything that we need to now recover the utility function. Why is that? Well, think about from what B of X is. From calculus, we know that that is going to be equal to B of 0 plus the integral, say we want to calculate at any x, from 0 to x of the area under this curve, because remember, this is equal to the marginal utility function. So it's going to be equal to P star, the inverse demand function of U, times du. And what is very cool, again, about this formula is that we can compute what the benefit function is based only on observables. We know the inverse demand function, and we know the x at which we want to calculate it. So we can fully recover the benefit function up to a constant. We're not going to be able to pin down the value of B0. But that's not going to be important, as you have been seeing in all examples and applications. The exact value of B0 doesn't really matter. There are some exceptions later on the course, but it's not important. So what do we have then? We have that because of the quasi-linearity, U of X comma M, which is equal, has this shape, is simply equal to the integral from 0 to x of P star U du, the inverse under the inverse demand function, plus M, and plus some undetermined constant that is not going to matter in most cases. This is, I hope you can appreciate that this is beautiful. This is almost magical. There is this very important concept in consumer theory called the utility function. That is something that is very hard to observe because we cannot open, at least easily, people's head to see how they are making their choices. And yet, as long as we can assume that they are optimizing, and as long as we can assume that preferences are quasi-linear, we can, from the observed behavior, back out their utility function. Many of you may be wondering what happens if utility is not quasi-linear. Since, after all, if you look carefully through the details of the previous derivation, we are really using the assumption of quasi-linearity to back down the utility function from the observed demand behavior. So let me make two comments about this. First is that we are okay, the method still works if the utility function is approximately quasi-linear. It doesn't need to be exactly quasi-linear for the method to be useful and to make accurate predictions. And that is not a bad assumption. It holds approximately quite well, although not exactly, but approximately quite well for many applications of interest. The second is that in more advanced courses in economics, where we study general preferences that need not satisfy this quasi-linearity assumption, one can show that the method generalizes. So the idea that you can back off the utility function and the shape of the preferences from the behavior is not really dependent on the quasi-linearity assumption, is much more general. And in more advanced courses of economics, they show you how to do that in general. The problem is that it requires a significantly larger amount of math that we cannot assume in this basic principles course.